Okay, so in our last session, we understand the concept of images layers, how to build the image, concept of Docker file instructions, difference between CMD and entry point. So there was one more thing. There are a lot of other things, but next to this, we have to understand about the life cycle of a container. Okay, so actually, if you install an application as a monolithic inside a virtual machine or bare metal server, so if that service is stopped, it will not affect the base operating system. But in case of container, each container can have a service or more than one services. So those services, normally each container has its only one service. So if that service is disturbed or crashed, your container will also stop. We did this experiment, but yesterday we ran, I think this was the Docker file. Yes, we ran this Docker file to build a basic image, and its basic process is ping. It is pinging to 111 until this ping process is enabled in the container will be active. Due to any reason, this ping is disturbed, mean ping process, not the request timeout or reachability. I'm talking about the ping process. Then this container will stop. So to prove this concept, what we can do, we can add, we have when we ping in uh, Linux, so we can define the counts of ping. I don't remember exactly the syntax. For example, I want to just ping 20 times. This is a syntax in Linux. I don't know what is syntax in Windows. So now a ping space minus C for count 20 times to this IP. And when this count will complete, this ping process will be killed and the container will also stop automatically. So let me just rebuild this image, or also I need to modify something else because the layers will not add until you are not going to make any change in the file system. So I'm going to just here run, for example, echo. The ping test image we built. So already the image was available. So it used the existing cached layers, just add the new layer. So now Docker PS, Docker images, and this ping test is 13 seconds ago, rebuild it. But now I will run this container. Uh, Tag is, sorry, not FD. Okay. Docker PS. After 20 ping, this container will be in stop state. See, this is exited. Why? because now inside this container, there is no ping process running. So we just prove that if the process within the container stop, the container itself will stop, because the purpose of this container is to just serve this service. So you can see the logs if the container is in execute state, Docker logs. Uh, this is the container ID. So these are all the logs. 20 times you can see it was pinged, it was completed. So this was the one concept. And the another thing, Docker images. Uh, I want to see how this image was built. One thing is I can go to upload this repository, and when I did this Docker inspect this image, I can see these are 4 layers in this image. But how these layers are built, what is included in each layer? So you can run Docker history command. Docker history command will show you the same output, just like I showed you in Docker Hub. When you go to tag, it will show you what instructions were used while building this image. So these are all the instructions. I use this instruction. I use this instruction. Whatever I use to build this container, it is reflected here. Okay, and these are the layers that came from the base image. What base image I use? I think I use the Ubuntu. Yeah, I used it. So these were the layers created by base image. So you can see each layer size is also mentioned. Every layer that make effect to file system will make a footprint of some size. These are just the commands. This is not making any effect on the file system. That's why size is 0 byte. Okay, so this is a base operating system, 76 byte MB, and the rest of all are 0 byte. Okay, so now we have to. Any question about this? Okay, now we have to understand the concept of multi-stage build. Multi-stage build, yes. So multi-stage build is used to reduce the size of your image. Right now, if I go back to the image, very first image I built, that was, I think, yesterday. Yeah, this one, Apache Elma Linux. So if I inspect this image, I can see, no, I think this was not exactly. Yeah, my website. This was just the Apache we installed, but with my website, we add more layers in the Docker file. Okay, so it has multiple layers, and its Docker file, I think it's Docker file. Yes, it's Docker file here is here. And these all uh, commands add a layer. This command add a layer. This is just an instruction. It is not making any file system. This command adds a layer. This one, these all add a layer. Expose will not add a layer. This will not add a layer. So now we want to reduce the size of this image. So you can see this wget. It is downloading the source code from some URL. Okay. And then we delete the source code. Actually, if you compare these three steps, if you understand these three steps, wget is basically pulling the code. Right now, we are using a code of HTML based or CSL or JavaScript based, but it can be a code of, you can say, Java or Node or Python or PHP or any other language. So you need to build the artifact of that code. For the Java, you need to build the jar or var files. For Node, you need to build Node modules. For Angular, you have to build for the HTML, CSS files. But in this case, we just pull down the code and we just unzip the code and we just move the code to the proper location. Just think about that. This is the building process. Just command will change in if you are building some node based project. We will do in our future classes in deep dive in Kubernetes. But right now, just think these three lines, these four lines are building steps of this code. In case of node, what you will write, you will wrote no npm install or npm hyphen I. It will build the artifact, node modules, dependencies, everything. For the Java, you will use the Maven to build the artifact. So just think if this is the building step. So we can build this, we can perform these step out of the box. One thing is this, that I download out of this container and everything I extract and I just run here a copy command to just copy the code inside var www.html. Why I wrote everything here that make an overhead on my image. One way is this. So in that case, I need to build a separate server. I should have a separate server that will perform these steps. And these steps will provide the final artifact for the image, where we have to place those artifacts inside the image. Whenever that image will used by a container will automatically use those artifacts and your service will start, application will be launched. So one way is to build the artifact out of the box, mean outside the container. It is a logic, your logic that it can be a logic to build the artifact, but multi-stage build is giving you a leverage to don't set up a separate uh, build server. Use the same container to build the artifact, uh, and it will not add additional layer. What we did, we build here and we add the layer. Finally, our work is done, but our image size is heavier, more layers. So multi-stage build will do the section explore the multi-stage. I want to show you the exact definition of multi-stage build. Multi-stage builds are useful to anyone who has struggled to optimize Docker file while keeping them easy to read and maintain. Okay, one task is also that easy to read, because a lot of steps you added, you can eliminate with the help of multi-stage build. So how multi-stage build will work? So this is an example. Uh, they use an image Golang. So Go is a language. So Golang container they use version
Okay.
1.2, 1.2. Yes, yes, please.
Will multi-stage reduce the size of image?
Yes, it will reduce the size of the image. Okay, so you can see here the Go language base container is used, and actually this container contains the Go language compiler. So for example, your developer wrote a program in Go language, and now you have to compile this code. And for to compile this code, you need this go command. So go build hyphen o is the command, hyphen o is the output, and this is the source code. Right now, this is very simplest example. This is just a four-liner code. Package main, import, FTM. This is something written by the developer that is just printing a hello world. This code can be thousands of lines, million of lines. In that case, you will copy the complete source code into your image at some location. But here, what they did, just straightforward use the EOF technology concept to just copy the create the main.go file, and this main.go file contain this code. So this Golang container is building the artifact under the bin with the name hello by compiling this code. So this is done. Now again the from is used, and scratch is some image. I don't know exactly what this image is, but think like this is some image, Ubuntu, Debian or anything. And in that image you finally need this compiled output binary, whatever compiled. This is you can say this is the artifact. This artifact you need. So what you did, you use copy, and here hyphen hyphen from zero. From zero mean this first from is known as zero. So the output of this first from, and from first from under the bin there is a binary hello, copy in this image under this location, and cmd command is used to execute this binary. Okay, so now your final image will only use these three layers. Okay, the base image layers, this artifact copy, and this will be your final running command. So how much layer you reduce? The building process, the code copy process, everything reduce. This is a helping uh, uh, you can say stage, building stage. Okay, go down. Now next I will, then we will build same like. It will give you the final image like this. It will use the final image by using this. This is just a compilation process. Okay, another example, the same, I think, yeah, same example they use, but here they mentioned as in front of from, as build. So they labeled this first building uh, Docker file part as build, and here they use hyphen hyphen from is equal to build, not zero. Last time they have not mentioned the first from first section as a name. Here they mentioned the name, and now they uh, mentioned here as a build. So from the build stage, there is an artifact available. Copy this artifact from build stage to uh, this image. So there are finally only three uh, layers you will be you can see. Okay, there can also be multi stages. You can see here as build one, as builder one, as builder two. So it is possible that your code need multiple time compilation or multiple artifactories. In that case, you will copy the relevant code in relevant build stage and build the artifact, and then copy the artifact from that specific stage. So here they just mention everything as builder, build one, build two. But if I give you example here, uh, they have not used, but they just mentioned. For example, this is build stage, copy from, and then copy. So we can use a multiple time a build stage. So let me just redesign this image, this Docker file. by reducing the size of this image. So how, what can I do? I will declare, actually I am using Alma Linux minimal. Okay. So what I will use from, and I can use Ubuntu or any flavor. For example, Ubuntu and as build, whatever name you can define here, build 123, whatever meaningful name you can say. Here you can say build stage. Okay. So now in this stage, what you need to do, you will copy all these commands. So let me modify this. For example, I will jump into the temp directory. Every Linux operating system, every Linux platform has /temp. So it's mean under the Ubuntu temp will be there. I am jumping into temp, then I am downloading the this artifactory. So other thing is I also need apt update, and also I need apt install wget -y, because wget is by default not available in Ubuntu. So it will download, it will extract, okay, and we don't need to do this step. We just have to, yeah, we just have to, Orex HTML will be the, just want to save this here. Orex HTML we don't need, and even we don't need to delete this because this is just a building stage. So it will unzip under the temp. Okay. Now, Alma Linux from label is good. We need to install HTTPD. Okay. We need to jump into this directory. Okay. We don't need this. We don't need this. No, don't need this. And we don't need to delete it. Okay. And now what I will do, copy hyphen from build stage, and under the build stage, under the temp, there is a name of the directory, this, uh yes, this directory, and I think I can also use just like this star. I mean, whatever under this directory, when this will be extracted, it will create a directory like this. That's why I copied here. So it will copy, and then I want to paste under the var www.html. I'm already under the var www.html. I will just use dot. So it will copy the extracted data from build stage to var www.html, and the rest of all is good. Okay, so this is the build stage from. We'll use the leverage of this build stage. So now let me Docker build -t, for example, web app 1. Just giving some meaningful name, multi-stage. Okay. Yes, wget was not there. It is installing wget. But you can see here it is mentioning build stage, whatever name we defined. Now it is downloading the source code. Now error came. Unzip. Anyone can tell me what is this error?
Yes, sir. We didn't mention the unzip package before
Where
on the upside. apt install wget. Uh, Also, we need
you
to
will no
mention
that you
unzip
you you
package.
will you will answer just like in the build stage.
Okay,
We have not mentioned. We have
but why?
not defined the unzip.
But why we have used like two times, like HTTP and wget in
Wh-
second
wh-
form.
Where is two time? Only one time I use work directory var
Micro DNF
wget.
install with
Micro DNF install HTTP and
yeah,
wget.
yeah, this one.
We don't need this. We don't need this. Yes. This is additional layer here. We just need Apache. Apache will create this directory and we just have to put it. Yes. Now again, we will build. Okay, this is successful. Docker images and it will show me the 4 seconds ago. Multi-stage build done. Now I will compare its layer with this image layer. So Docker inspect. Mm, no such file. Such, oh, sorry, hyphen. You can see the difference. 6, 7 layers. Now it has only 4 layers. And your size difference. Size is 164 megabyte. Its size is 162 megabytes. This is not a big difference, but we understand the concept how we can reduce. When you will build the artifact in the practical life, you can reduce a huge size. So I can reduce the size with one more example. For example, I can pull down the source code out of the in parallel to Docker file, and then I can copy within the. That is also a way. But in that case, actually, my code is not compilable. It is just unzipping the code. So, but we look a clear difference in the layers. And when I will run, now I will run a container Docker. For example, one container I am running on 8181. I think, yes, it's port 80. Another container 8282. And its image. Okay, both are running. So both will show me the same web page. 8282 and 8181. Uh, 8282. I think, yes, there is a problem. Whole code is not completed, copied, something is missing. some part of the code is missing. Yes, this is working fine. Yesterday we built, but today we build has some deficiency. Yes. So what can be the reason? How I can verify? I will go under the 8181, this Docker. Uh, uh, Bash. Sorry, not run, execute. So I am directly in the HTML and it just copied all the file at the same location. So what is the problem? If I go in the second image, second container, not image, this is working fine. You will see here the code is quite different. Here the three directories are there and code. So what error I did, what mistake I did? Actually, I need to, when I did this copy, I put star. So this make some problem. I want to copy the whole content to this location. Okay, let me try this one. This is the scenario where I must have to delete the image because already the artifact is copied to the web root. So when I will copy again, maybe it will copy the right data, but the older data will also be available. So this is the situation where I must have to delete the image. Yeah, this time is good. So now it's mean this command actually copy the all the content under this directory to current location. So now both are working fine. 8181 is the multi-stage, 8282 is without multi-stage. Both are performing same services, both are providing the same services but with low disk space usage. Okay, so this was the multi-stage build concept. So any question about multi-stage build? So we can add as many stages here. Let me give you another example.
I have the question.
Yes, please.
Yeah, actually the same things we have performed earlier from the from and the label we put runs there, but before the run, so we just put the things top of from the Alma Linux, right? But what if I saw we saw that the layers decreases from 8 to 4. So the codes was pushed there automatically and we run it. But why it's how the compiler read it? So actually, sorry, I do not understand this thing.
I mean, how, when you need to understand The final image build only use this step.
Yeah. Actually,
This is just a helping step.
yeah, but we study one the run command that's create the layer, right? We sorry, yeah, layer. One run command would create one layer, and two
Yes.
runs
No,
command
no,
that
not
create two.
not every time run command. Copy will also, add will also. These all will add the layers. Okay, now,
Okay.
what's your question?
My question, if you see in this in here, so we have how many run command? We have five run commands, right? So how many layers will be created against in these run command?
This is these are four and this is five.
Yeah.
So actually, the final image is only using one run command.
Okay. So means the above the we can say the above will be put in the temp, right? Temp
Hmm.
directory or something like that. That is not or just using where. So what is the layers technology? How basically the layers basically work based on the commands we run in the compiler. It will once we run the any run command, so it will create the layers, right?
Yes, it will create the layer.
Okay, got it. Yeah. That's actually I want to ask now.
Actually, no,
Yeah.
you just need remember one thing. Whenever you are making any change in the file system of the container, mean you are creating any directory, any file, or modifying any file. Okay, in your Docker file, that will create a new layer of some size. Otherwise, I showed you the layers with 0 KB too. That will not affect the size of the image. So think about where there are a lot of instructions I showed you. I have not used all the instructions. So whatever instruction you will use in your practical life, just think if that instruction is adding something new inside your image, that is creating a new layer.
Yeah, Same. The My question: if the four runs, if I drag down at put in the end script, the
Mhm,
layer will
mhm.
be added. So
Yes,
so
it will
what
be.
is the reverse engineering behind there? If I move these run commands on the top layer and put it on the Ubuntu container,
Mhm.
that's do not create the layers. But once I move these runs at the end of the Alma Linux or the main instruction, there the layers will be added. So what is the philosophy behind this? How it is working? So this is actually my question only.
No,
I
last
think,
time.
sorry,
Hmm.
if I can add something, I think Yasir, you are adding both portions of the file. As Asim told, the above portion of this file has four runs, but it has nothing to do with the lower portion. It has a one run. I think if I can answer you.
Yes, this is the answer. But yes, sir, you remember when I start editing this image, I cut paste these run commands from the lower part to upper part.
Yeah.
So lower is the final one.
Okay.
Whatever will go inside the image is the last from, and rest of the commands will decide what stuff will go inside your image. Rest of all are just producing some stuff, and by taking the leverage of this syntax, you are copying from those layers to copy the data inside your image. Just like I'm giving you another example. I am using this time Alpine. I know Alpine. Uh, Sorry, I cannot give exact example. I'm not getting the point. But inside the Alpine, no, okay. Inside the Alpine, I just ran echo. Yes, I got it. Echo some data. Okay, and I throw this data under the temp. Think like this is under the temp. You can say artifact uh, 2 dot txt. Okay, it will create a file under the txt. Now I want to put this from build stage 2. Okay, and what I will write here from build stage 2 from this location, copy to, for example, here, the same location under the web root. So now I am using two stage build. This is stage 1, this is stage 2. It is producing the source code, compilation, everything, unzip, and it is producing this file. So now I will build the image, and I will show you the final image will have this file. Right now, if I docker, yes, right now, this container docker, there is no file like artifact.txt. Okay, so now what I will do, I need to stop this container. Now I will, you can see build stage 2 and exporting layers, and build stage 2, 5 out of 5, copy this artifact. Now I will again run multi-stage build. I'm running this container, again going inside this container. Sorry, this time the container name is changed. This time container name is C7. C7 is the unique, this is the ID. From here I just took C7. And PWD and ls. Here you can see artifact 2. How this is created by whatever I wrote in the second stage. So just think anything, any project you got, and you just have to understand how to compile that art code. So, and then you can build the final artifact and in the final image.
Yeah,
Okay,
great.
so there are now two benefits of this multi-stage. One, you save your build server. Uh, you don't need any build server. Just directly write the Docker file that will, every time when this Docker file will run, it will automatically do the compilation, building the code and putting in the final image. You save your server. But what is, and the second thing is, uh, you don't need to build the image, you reduce the layers of your uh, image. But the disadvantage is it will take more time and it will take more resources. And when you are running on cloud anything, it is your bill is based on your usage, CPU, RAM, whatever you use. On the basis of that, your bill will be calculated. I hope you got the idea.
Yeah, yeah, Asim, now it's clear. So last thing, if I want to see that how many layers, 4 layers are created, right?
This will have one more layer. Uh, Now, if I, what was the, just, uh, mm, Docker inspect. Now it has 5 layers because I add one more file. That's why.
And I want to see in the start of the video. So we you showed us that there is against the layers we have some commands. So associated commands. Can you show
Mhm.
us this?
Docker history and the, sorry. Docker history. So this is reverse engineering of any image you can do, or you actually what is happening when you are pushing this image to cloud to your repository. What is happening? Actually, this Docker file is going inside your repository. In actual form, all layers are going. So when you pull down, all layers are downloading. So for example, you upload 10 images. Okay. And so images can have common layers. In that case, all layers will not be copied on the your repository. Only different layers will be copied. It will take the repository is intelligent. It will take the leverage of existing layers by another image. Okay, clear?
Yeah, thanks a lot. Thanks a lot. Much appreciated. Thanks.
Welcome. Okay, so we understand this about the concept of multi-stage build. So this was, I think, last session for the Docker. There could be some other stuff too. Let me just take a quick look here. But this is the most imperative and mandatory part you must have to understand while working as a DevOps engineer. You understand the most important part here, the building of image, the uploading the image, and you download the image. I build the image and you download the image. How much time it took? Only the bottleneck was the internet bandwidth. You have huge, fast internet speed. Within seconds, you can migrate your application, build and migrate your application anywhere in the world. So that's why the Docker, the microservices technology is the core of DevOps. Think about if you want to move some virtual machine. There is no proper protocol to move a virtual machine from. There is no concept of repository to host the. You export your image in OVF format. So OVF, I believe, only supported by Hyper-V and ESXi. So other hypervisor will not support it, and then you need to take care the variant of the OVF exported, the virtual machine variant. If your hypervisor, for example, you exported an OVF from hypervisor ESXi 7.0, and you are going to import it under the 6.7, it will not import. So there are a lot of dependencies. And then where do you will upload? You will upload in some Google Drive or S3 storage or anywhere, and then you will download. It will take a lot of time. So we are done today with the Docker portion. And from next session, we will start the Kubernetes. For the Kubernetes, you must have to set up 3 virtual machines at least. And for the production grade POC, I will give you where just I want to give you an idea what infrastructure we are going to use and how the Kubernetes architecture will work. So actually, we need at least 3 master nodes and then worker node, as many worker node you can add. So master nodes are always in odd number. You can set 1 master node. In that case, your HA will be your master node failure can make your whole cluster fail. So 1, 3, or 5, or 7, or 9 quantity you can set. The reason of odd is the election is happening among these master nodes. So election cannot tie when there are odd voters. So this will be our master node.
4 GB will be enough.
Yeah, 4 GB each at least.
Okay.
Uh, Actually, these three are master node, and the lower one are worker nodes. I will show you on my laptop. My laptop has 32 GB. So, and on top of this, there will be a load balancer. We can use the hardware load balancer too, and for POC purpose, Red Hat is using normally HA proxy. So this will be our load balancer. Load balancer will connect with all your master nodes, route different ports, port forwarding, load balancing, not port forwarding. It will receive the request and will round robin forward to multiple master nodes. And then these are the worker nodes. Worker nodes are actually having uh, the final application deployed. Okay, so worker one, worker two, worker three. So, but for the if you have less memory, then you can use only one master and one worker, or at least two worker to clear the concept, because with one worker you will not clear the concept. So in next session, we will understand the Kubernetes complete architecture, what type of services are involved, and how Kubernetes is mean why Kubernetes is used as a orchestration tool for the microservice. There are other tools too, like Docker Swarm, but Kubernetes is most in. So that's all. Any question about anything so far we learn, or today some people contacted me on WhatsApp. So they had some question. If they joined, you can ask the question.
One question about the multi-stage build is what about, I mean, the developers has used to use the multi-stage build, or they use the simple stage? Because you said in the start that the multi-stage build takes much time as compared to the simple build.
No, it will not take much time, because it will take almost the same time. I gave you the more time taking example when you are building within your image. When you
Okay.
are building out of the image, you already build the artifact, and you put the artifact in parallel to your Docker file. Use the copy command to copy instructions to copy the artifact within the image. That will not take time. Okay,
Okay,
so
another thing.
multi-stage is always used when you are going to build within your image.
Okay. And one more thing, that when you are editing the Docker file, how do you know that you are editing the exact Docker file what you are building? Because when you uh, type the command uh, Docker file, vim Docker file, whatever the syntax is, how do we know that what image we are working with?
No, you will create a multiple directories, and each directory will have a separate Docker file. Otherwise, if you are making multiple Docker file within a within the same location, then you will create another Docker file, just like another Docker file name. You can say ABC. Okay, let me give you the example. For example, this is your Docker file. Here you tore out from Ubuntu, sorry, you small, and what you did run apt update run a- apt. Okay, so ping is installed. Now this is your another Docker file. ABC another Docker file. This is the another Docker file. Now how you will use this ABC within the same directory? You will use docker build -t new image name is this, and you are not going to use dot. You will use -f flag followed by the file name and then dot. Dot mean in this directory. This ABC you have to use. If you are not going to provide this one, it will use a default file name. So now why it use cached, because yesterday we did the same thing and those were already available in the system. So it is not using the rebuilding of whole step, but you have another image. What this process did, what was an image name I did? Yeah, new image. 35 hours ago, it is using the same layers. That's why let me delete this. Let me delete this ping test. Let me just delete this. Ping test. I think still new 35 hours ago. Ping test is available. There is still something new. So this time you use a different file. With this way you can use
But if you type vim docker file at the same path, what file will be opened?
Docker file. Cat ABC, it will open the ABC file.
I I have one more.
Whatever
Usually,
written in the Docker file is there. So this is not a good practice. You will use a separate directory to build the image. Each directory will contain a separate Docker file and its relevant files you want to copy inside your, because when we are running